Welcome back everyone to another project, and this one's probably going to be a bit of a basket case if I'm honest. So this is the Luxman D-105u. This is their tube hybrid CD player. I don't know if this is like the top end of the Luxman CD players. I don't really know the lineup. I'm not a CD person, but this is sort of the matching CD player to go with the LV105u amplifier. I sort of just crossed paths with it. It was broken, and I decided to grab it to try and match it up and have a complete set. So the CD player had the same issue as you would have seen in the DZ111. The belt was screwed. Replaced the belt. Put this thing back together, and I don't know if it was actually working or not because I never got that far. And basically what I did is I plugged in two connectors the wrong way around. They're identical connectors. I mean, one's red, one's white, but they physically will fit in each other's sockets, and basically nuked the CD module or the CD transport. So we've got to replace it. We have one here, like I talked about in the previous video, out of the DZ111. We're going to swap that out. Now, I don't know if this is going to work or not, so I need to be super clear about this. This driver chip got really hot and started to burn up. I caught it just in time, and I think it's still alive, but it may not be. And we may have to find a new driver chip as well. So, and I don't even know if this thing worked, period, because we never got that far after replacing the tray belt. Anyway, so this is the 105u. Like I said, it has tubes in it. It's a very weird design. Someone has messed with this already and done some weird things. We will go over the design of all this, and I'll show you around this unit afterwards, but let's just see if we can get this thing working before we get too carried away with this project, because it may be not repairable. I don't know. Anyway, we're going to swap out the CD transport first up. Then we're going to see if this thing actually works, if it needs calibration or whatever, and then we'll go over everything. So let's get started. Now, one of the things you notice straight away, it's got a nice thick bottom plate on this unit. We need to take out the 6 screws on the bottom. I just found this out last time because the rails kept stopping the CD transport from being removed. So yeah, I just found it easier just to remove the whole thing. It does have little tabs that sort of hold it in. So we're going to try it this way this time and see how we go. So 6 screws on the bottom, and then we go back to the top. All right, I'm going to just try taking out these 2 screws on the PCB, which sort of hold the top of the bracket, and see if we can slide this whole unit out. Otherwise, we'll remove the transport screws as well. So this is either going to work or it's not. I think it is going to work, so I'm probably going to take it out this way. Disconnect these connectors, and hopefully get this thing out. Maybe not. No, I'm going to split the rail again. So under a couple of transport screws. This is pretty much what I did last time. And this rail will just fall away from the transport, and yeah, hopefully it just comes out like that. Woo! Okay, so got the CD transports out. I'm just having a look over them. The transports themselves are identical. I can't find any differences there, but these laser modules are not the same. So this is a KSS152A, which is what is listed for this CD player. But you can see this is a plastic body. The metal housing is for the laser unit, which is there, but that's plastic there. On this one, it is all metal, all the way down to the supports. And that is obviously different. The markings on this don't really mean that much. I don't know exactly what's going on there. So the connectors are the same. All we can do is try it really and see what happens. I was trying to find out what was wrong with the old one, like what the hell got burnt out in it. The resistance for the focus and the tracking seems, I mean, it's different, but there is resistance on both these units, so I'm not concerned with that. I did find resistance on 2 wires on this connector for the one that's damaged, and this one is just open circuit across every wire. So I'm assuming something is partially shorted or burnt out on that one. We don't know yet. We will put the new one in and see what happens. We've got to swap these brackets over first. Put it in and see what happens. I have a feeling it's not going to work. We're going to have to try to calibrate this thing. But we're going to try and just go one step at a time. Okay, transport is back in. Try a disc. I'm assuming not much is going to happen. It's doing something. No. No read, no tracks. All right, let's have a look with the oscilloscope and see if anything is happening. So there is activity on that driver. Obviously, we can't really make sense of what it's actually showing us here, but there is something there. And tracking is also showing a little bit of activity as well, but nothing crazy yet. So let's consult the service manual and see if we can get any hints on where we go next from here. All right, I decided to backtrack a little bit. I've put the transport back in the DZ111 because this is a working CD player that we can use as a reference for troubleshooting. And we also have the service manual. So we're going to use the resources we have available to try and isolate and just sort of take bite-sized chunks out of this and work out what exactly is wrong with the D-105u, because it just won't, I'm not getting anywhere with it. So anyway, we start with a service manual and it's talking about like just basic operation checks, and it says that the optical pickup, it moves in the outer circle and inner circle directions, and that is referring to this, the sled here should be able to move as part of the detection process for CDs. Laser beam emits spreadingly. I love this wording. It's amazing. So that's basically saying the laser works and does something. We can check voltages on that. I'm not keen to look into the laser to try and see if it's working, so we're not doing that. The objective lens perform up, down 3 times. Oh, this wording. So it's basically saying that this should move up and down 3 times. So this is our benchmark, our reference. So let's see if that what they're saying there is actually correct. Okay, so we had the 3 operations of the focusing. The sled homed itself, but I don't think it moves anywhere other than home. No, so it's just sitting there. I've removed this top spindle assembly so we can see everything that's going on. We can't put a CD in there, obviously, or maybe we could, I don't know. But yeah, so that's what we should be seeing, because even though this is a different unit, the operation of this is basically identical. All right, so we've crossed 2 things off the list there. So what else are we looking at? So basically the 2 connectors we got screwed up when we were reassembling were these 2 4 pins, which correspond to these 2 areas. Now, this one does the tracking and focus and also the sled movement, which is interesting, which goes to that driver chip, which got really hot in the other unit, which we need to work on. Now, this other one is the laser pickup. So I went and checked all the voltages here, and we're looking at 1.8 volts. The ground was just 2.2 millivolts, which is nothing. This one was minus 4.79 volts, and the last one was minus 4.96 volts. I also confirmed that the sled has minus 2.53 volts on it when you load the tray. The reason why I wanted to check this, and I was quite surprised about this, is that the driver chip that got really hot, that we're concerned about being burnt out, goes to that 4-pin connector, but it also has a separate connection going to the sled driver motor. And that is on a completely different connector, which we haven't messed with, which is an interesting little gotcha. So, yeah, there could be a problem with this still. And I'm a little concerned about this sled because I don't remember it moving in the other, the D-105u. So we're going to go back and have a look at that. But we've got voltages for this top one, so we can check the operation of this chip to make sure we haven't burnt that one out. And we can pretty much check this as well. When it comes to the focusing and the tracking, there's not much we can do there other than just checking to see if it actually moves, because the voltages are sort of oscillating and it's just a bit all over the place. I have some measurements, but there's nothing fixed. It just sort of jumps around. So we're just looking for activity more than sort of a fixed value, other than the sled voltage, which we've got there, obviously. So I'm going to put this back in the D-105u and let's compare, and I think we're going to find something. Okay, so I got the transport back in. I've just been sanity checking, comparing my results, and what have I found? Well, the sled does not budge. It just sits there. However, the focusing is working, and maybe the tracking, I don't know about that because we can't get that far yet, but this is not homing itself. So yeah, I've been comparing the voltages on the laser. Everything is fine there. The sled has no voltage whatsoever, which is coming from that driver chip. However, I did check the IC, which is the microcontroller that runs that driver, and we had minus 3 volts on the DZ111. We have minus 5.3 volts on the D-105u. So the IC, or the processor that's running the show, should be fine. However, we have a problem with this driver chip, which is not good, unfortunately. I'll show you on the schematic. So I've just sort of dragged out the highlighter a little bit more. It's trying to work things out. So this red is what we're dealing with. This is not working in this portion. We have no voltages here. However, the control voltage that is driving it, which comes from the microcontroller, is working fine. We can measure that. So we've been able to trace working operation up to this chip, and then from this chip onwards, we have no success. However, the other outputs on this chip, which are actually on the connector that we messed up, well, I messed up, seem fine, which is just really weird. Right, so this chip is dead. What are we going to do? Well, unfortunately, I think this project's a bust and this thing is just going to be a paperweight or parted out. because this chip is just too specialized and I don't think we're going to find it anywhere. Actually, I'm just kidding. I managed to get 2 chips. I couldn't believe it. I actually found 2 of these locally, and these look to be legit, and I'm hoping they are. Postage was really expensive, so I just grabbed 2 of them because they're like $8 each anyway, so why not? And I just cannot believe I managed to get a chip like this in this era. So we are going to change that out. We're going to pull this whole board and be careful with all this ghetto wiring that's been done. Swap that chip out, and hopefully this will home itself, and we are on to the next step, whatever that happens to be. We'll see if it works. So let's change that out. Okay, moment of truth. Got the board back in. It's just sitting in here at the moment. We just want to see if this does something different. And this is like the normal warm-up mode for this. But will it home? Let's make sure that chip's not getting too hot. No, feels okay. Close the tray. Oh, look at that. And it's still doing its thing. Okay. Sled moves. Excellent. All right, got the top spindle support remounted. It just sort of clips in. It's very easy to remove. Gonna try my amazing test CD. Spin, please. Oh, look at that. Wow. Holy crap, it worked. 3 tracks is correct. Can we play? Oh, look at that. It's working. That's amazing. Takes a little while to skip tracks like the DZ111 did. But it's working. There you go. It's fixed. We've still got to calibrate this thing. I have a feeling because we swapped the laser module and it was probably out of calibration anyway. So we've got to go through all these trim pots, test points. There's all sorts of crap we've got to do here. I've already had a bit of a look at it, and they've done an amazing job labeling all these connectors. Look, you've got all the rail names and functions and whatnot, but none of the test points exist. Nothing is labeled on this board for test points, and I'm still trying to work out what we need to do there. So I think we'll save that for the next video. This one's probably long enough already. We'll do a follow-up with this. We'll go through the calibration and see if we can just sort of work everything out together. Hope you enjoyed the video. I'm glad I found this chip, because otherwise this project was done and we weren't going to get any further with it. So yeah, stay tuned for next video, and I will see you in the next one.